Hello, I'm Stefan Kreber, I'm project leader for LXD, and this week in our video series going through LXD device types, going to be looking at the PCI device type. This one is a slightly special in that it's, I believe, the only one. Yeah, I think it's the only one. Device type that's only supported on one instance type. In this case, it's virtual machines. That's because you can't actually do a pass-through of a PCI device to a container. That's just not a thing. And it's also one of the simplest device types that we have, at least as far as configuration goes. It only supports a single config key, the PCI address of the device that needs to be moved into the virtual machine, and that's it. Now, that's not to say that it's not complicated behind the scenes. Doing PCI pass-through is not trivial. There's a lot that needs to be done right for it to work. On the ease, like on LXD side, what that means is that it effectively locates any driver that might be tied to the device, detaches that, and then reattaches the PCI device to a dummy driver effectively, which is then used to pass it through to the PCI bus of the virtual machine. LXD allocates a PCI address on that PCI bus and makes sure that it's at the right speed and everything looks good. But for any of that to work, you actually need to have a system that's compatible with this. That means you need to have the right kind of virtualization extension, which most CPUs support these days. It's VTD on the Intel side. I don't remember the extension on the AMD side. But you also need the right firmware, in some cases the right motherboard for this stuff to work. That's because a lot of systems, especially the more consumer grade ones, have a tendency to share PCI lanes with multiple devices. That's simply because consumer grade CPUs at least used to have a lot fewer PCI lanes than the more modern ones. And there just wasn't enough lanes to go around. So as a result, you often have things like your SATA controller and your sound card, or SATA controller and your USB ports or something like that are shared. They use effectively the same lanes with some kind of PCI bridge switch type chip, or they go through a chipset or something like that. In any case, the result of that is that they can't be fully separated as far as what the CPU sees. So they can't get their own, in this case, IOMMU group, which then makes it impossible to safely detach one device from the whole system and pass it to the VM without the other device that's in the same group also being moved at the same time. So that can be a problem. On most motherboards, whatever slots are used for the GPU are pretty much guaranteed to go straight to the CPU and have nothing else sharing those lanes. So that tends to be safe. But it's also problematic for GPUs anyways, because you can't easily detach your main GPU. It's just gonna go and crash your system. Anyway, the other thing to keep in mind with that device type is that it's not for all use cases. I did mention GPU. Those, like if you're trying to do GPU pass-through, you should actually use the dedicated GPU type instead. It does a few more checks. It's more flexible as far as how it selects the GPU that you want to move. It supports things like virtualized GPUs as well. It does SIOV, it does that kind of stuff. Same goes if you're looking at the network card. Chances are the NIC device type is actually a much better bet for you. Because that again supports different ways of selecting the device. It also supports using SIOV to get just a VF out of the device. It's just more flexible. The PCI device type is effectively for other cases. That can be because you want to move a USB controller card over to a virtual machine, or a sound card, or video capture card, sound capture card, an FPGA, any of those kind of more specialized single function cards that you might have around. Those you can pass through to a virtual machine using the PCI device type. Now that being said, for the demonstration, I don't actually have any such device. I'm going to be using a network card. This is going to work just fine. Like you can't totally use the PCI device type directly with a GPU or network card. It's just making your life slightly harder because you need to figure out the PCI address instead of using some other way of figuring it out, and there's going to be less checks done by LXD to make sure that your host system is not using that particular device. All right, so let's go and look at an actual system. So here I've got a Ubuntu 2204 server. I did have to turn on IOMMUs in the Linux kernel. So you can do it, and that's kind of what we use in our test suite, which turns everything on. So it turns on IOMMU into pass-through mode, it turns on Intel IOMMU, and it turns on AMD IOMMU. What that does is that it will effectively negotiate with the firmware to get IOMMU groups properly assigned to all of the devices, and that gives you a decent chance of getting groups that are not shared with any other device so that you can move devices safely. You can try and figure that stuff up on the booted system by looking at your PCI output. In this case, you can see I've got a lot of devices that come just from the CPU itself. So I can filter out anything that comes from the CPU by ignoring anything that says Xeon, and then filter out any of the chipset stuff by ignoring everything that says chipset. And we're left with mostly what's available on the system. There's still a memory controller that I can also effectively, well, it's an SSD actually, never mind. It makes sense. So here we're left with a PCI bridge, a few network cards. So we can see an Intel 10 gig card, an Intel gigabit card, a Realtek 2.5 gig card, Mellanox 40 gig card, the PCI bridge to the BMC that includes a VGA display. There is a SATA controller card and more networks. So we've got an Intel gigabit card and two Mellanox 100 gigabit cards. And lastly, an NVMe SSD. So of those, the ones I definitely don't want to touch would be the SSD. That would immediately crash the entire system if it was to go away. I believe one of the 2 gigabit cards is used for the network right now. So if I was to move that one, it would be a pretty bad day. I also don't want to touch the SATA card because I might actually be booted on the disk that's attached to it, and removing it from the system would not be good. Same deal with the graphics card. If you remove that, there's a good chance you're going to panic the system. So in this case, I'm effectively left with network cards. And for a demo, we're going to be using the Realtek card here because it's a nice and easy one to play with. So in this case, we can see that its PCI address is 02.00. There's hopefully nothing else that it's sharing its group with, but you can do the LSPCI in verbose mode and then go look at the outputs. If we go search for Realtek in there, we should find the Realtek card. There we go. And in verbose mode, you can see the IOMMU group. So IOMMU group 28 is what we're looking at here. So I can go look for anything else in the group, and there's nothing else. So that's good. It means the device should be perfectly fine to detach, move to a VM, and reattach to that. Now would be usually a good time to make sure you're not actually using it. In this case, I know I'm not. So next step is to just launch a virtual machine. So there we go. Just downloading VM image and then starting that VM. At this point, just starting it blank with the default set of LXD devices. Once that's up and running, I'm going to shut it down and then add the extra PCI device. Come on, there we go. All right, so it's been passed through, and let's install PCI utils. Okay, glad that it was still running. Now we can install PCI utils. There we go. And if we look at the PCI bus in that one, it's reasonably boring. There's a bunch of reserved PCI ports here. And then we can see all of the VirtIO devices that LXD uses. So they're all listed as Red Hat VirtIO. A SM bus controller that's virtualized as an Intel one. There's a SATA controller that's also virtualized as an Intel one. And that's effectively it. So now let's go ahead and shut that down. Look at our PCI output again for the PCI address. Okay. And then we can add it to the VM. So let's call the device just foo in this case. The type is PCI and the address is 02.00.0. Okay, and then start it. And when we do that, effectively what will have happened is that the Realtek driver would have gotten disconnected from that card. Then the VFIO placeholder driver is attached to that PCI address so that the Linux kernel on the host doesn't mess with it. And that's then exposed to QEMU that connects it to the PCI bus inside of the virtual machine. If we look at the kernel log, sometimes we can see what's going on. In this case, there's not a lot to be seen really. The main indication that something's going on is a couple of log messages from VFIO PCI, but that's pretty much it. Now going inside of the virtual machine, we can see that there's an extra device now on the PCI bus here, address 6, which is the Realtek 2.5 gig controller. So exactly the same thing. And we can just, if we wanted to use it, it should actually show up. Actually, it doesn't. That makes sense. I believe we simply don't have all of the drivers installed out of the box. We run the Linux virtual driver in here. If we look at the driver we've got installed, instead of running the generic driver that comes with everything else. So we could install generic. Just gonna bring up everything else that's needed here to load those kind of drivers. So that's something to also keep in mind with LXD. Our images are designed to be as small as possible, effectively. And the way we do that is by not shipping a kernel that has every single driver supported, because most of the time you don't have those kind of devices. But if you're starting to do PCI pass-through, then it starts to matter, because like you're gonna need drivers for whatever you're passing in. And so usually we'll need to install a more generic kernel that comes with all of the extra drivers. In this case, it's the Linux modules extra package that we really need. And that's gonna bring in what we need. Once it's installed, you could just load the driver. In this case, we're just gonna be restarting the virtual machine, and that should give us the right driver loaded on startup. So that's just something else to keep in mind, that yeah, most virtual machine images don't actually have the drivers for physical devices because they're virtual machines. Starting to regret not having given more CPU or memory to that virtual machine. It's a bit slow. All right, so that's all installed. Let's just reboot it. And as it comes back up, we should be getting our driver. Just one thing that we will probably notice during the reboot, potentially. I'm just checking. Yeah, I think we did. Okay, so during the reboot, the Realtek driver got reattached to the host, so we can actually see it loading up here, and then promptly going down and getting going through VFIO PCI again. So that's something that makes sense. Like as the VM is shut down, the device is returned to the host, so the drivers load back there. Okay, so now if we look at our VM, we still have the device here, and this time around we do have a extra network device showing up. It doesn't have an address or anything. I'm not actually sure that this is even connected at all. I can just try to get an address from it, but I'm not so sure that there's physically anything connected into that NIC. Doesn't look like it. Did that bring it up? It should have. Oh yeah, okay. Yeah, it is up. It shows no carrier, so there's just no physical cables plugged into that card. But that does show how to pass through PCI devices. And if that had been a sound card, FPGA, or anything else, it would have worked the exact same way. I can just go look at the config again for the VM, but it's pretty straightforward. It's just type is PCI, address is the PCI address, and you're done. Maybe one thing to just keep in mind there, PCI addresses are stable so long as you don't unplug or plug anything in your machine. If you were to plug anything else in any of the other slots, it might just shift everything by one. So you want to be a bit careful with that. If you often reconfigure your machine, and you've got PCI pass-through configured in some virtual machines, you might need to go after any kind of physical change and make sure that all the addresses are still pointing to what you actually want, because they might all have shifted by one and you might end up passing through the wrong devices kind of all over the place. So just something to keep in mind. And that's it. If you've got, switching back to the documentation, there we go. If you've got any questions about this, I can just leave them down below on the community forum. I'm going to be including the link to the documentation, even though it's probably not really needed, given there's literally a single configuration key for it. But yeah, that's how to use PCI devices with virtual machines. Again, might not work so well if all you have is, say, a laptop. Even with more modern laptops using Thunderbolt, I'm not sure what the IOMMU setup is for that. So I'm not sure that you could just plug a Thunderbolt device and then pass that through to a virtual machine safely. But it's something you can check by first enabling IOMMU on your system, and then by looking at the LSPCI output to check what the IOMMU groups look like and making sure that everything will behave. All right. So thanks for watching. I'll see you in the next one. Bye.